Hi viewers, you are all welcome back to Prof 1 Tutorials. My name is Alfred Amprofi, and today we are going to look at another aspect of mensuration 2, for which I have titled it cone. We all know that cone has a circular base, and we can also call it the circular pyramid. So viewers, let's look at how a cone looks like. Alright, so viewers, what we have here is a circular pyramid. So a circular pyramid is a solid figure which has a circular top but a conical base, or it can also have a circular base but a conical top. So over here we call it the apex because it's a pyramid. Then its base is in a form of a circle. So from the fig A, so let me name this one fig A. From fig A, this is the radius R, and then this is the height H. Then from fig B, this is the radius R, and we have the height H. Notwithstanding, this side can also be the apex because we can just turn it upside down. So this is our fig B and then the fig A, for which they are all cone. So now we are going to look at how we can find the volume, the curved surface area, and then the total surface area of a cone. But before that, let's look at some examples of cone. So the first example that we can use to identify cones, I can talk about funnel. So we can see that a funnel looks like this, which has a circular top and then a conical base. We can also talk about Christmas hat. So Christmas hat, it also looks like this. So you see that they will put it on their head, then there will be a rope which they tie to just dress when it is time for Christmas. We can also talk about birthday hat. Birthday hat. So sometimes birthday, it also looks like the Christmas hat. So they still put on their head, then there will be a rope around their chin they will tie, and then they dress with it. Then the last one I am going to talk about is ice cream. Ice cream. Sometimes we put an ice cream in a container which looks like a cone. Then the ice cream, we'll put it here. You hold the base, then you use your tongue to lick, and it's really, really nice and sweet. So sometimes when you go out with your children, then you buy them ice cream, they will just be eating and they will be enjoying themselves. So this can also be in the form of a cone. So viewers, we are going to look at how we can find the volume of a cone. Of a cone. All right. Now, because a cone is a pyramid, then it's going to be 1 over 3 multiplying the base. So here the base is in the form of a circle. So area of its base, which is pi r squared, times the height, which is h. So basically, this is how we find the volume of a cone. So it's always 1 over 3 multiplying the area of its base. Okay, so 1 over 3 generally multiplying area of its base times the height of the pyramid. So we still have 1 over 3 times area of a circle. The base is in the form of a circle times the height of the pyramid times the height of the pyramid. So basically, this is how we find the volume of a cone. All right, so now we are going to also look at the curved surface area. The curved surface area of a cone which is equal to pi rl, where the L here, we call this side the L, so we call it the slant height. That is the L. So in this case, this side can also be the L. This is the slant height. Okay, so when we look at this figure here, this part is the slant height, or we can even or this is the curved surface area. So this whole side, this one side will be the slant height. But if you're asked to find this curved surface, you see that the surface is curved. It's in the form of a curve. So we call it the curved surface area of a cone, which is given by pi rl. All right. Then the next part is going to be the total surface area of a cone. So let me put it here. So we have total surface area of a cone. Total surface area of a cone, which is equal to, now from here, if you are asked to find the total surface area, it's going to be the area of its base plus the curved surface. So the base is pi r squared plus the curved surface area, which is pi rl. So sometimes you can do some factorization. So pi here, we can factor pi out. R squared, another r, we can factor r out. And it will be left with one r here, so that when they multiply, we can still get a pi r squared. Then pi r has been brought out, so it will be left with only l. So pi r bracket open, r plus l will be the total surface area of a cone. So viewers, we are going to look at one example under circular pyramid, or basically we call it a cone. So stay tuned and let's continue. Example: a sector of a circle of radius 5 centimeters having an angle of 216 degrees is bent to form a cone. Full stop. Find A, the radius of the base circle of the cone. B, the height of the cone. C, the volume of the cone. Then D, the curved surface area of the cone. Then the last one, E, the vertical angle. Bracket open. Take pi equal to 3.142. Take pi equal to 3.142. So let's begin. Now the question said a sector of a circle. So let me draw a circle here. Radius 5 centimeters having an angle of 216 degrees. This means that the sector is a major sector. So I will take this one to be my center. We have radius 5 centimeters, another radius 5 centimeters. And because the angle is 216, then the angle will be formed here. So this is going to be 216 degrees. Then that sector is bent to form a cone. So it means that this whole part is off. So now this has been bent to form a cone. So viewers, I have something to describe. So let's say this was the circle the question was talking about. Then this has been cut off. So it will be left with this sector. And this is a major sector. So this sector here is bent. So I'm going to bend it like this to form a cone. To form a cone. So this is a cone. This is a cone. Okay, we can also put it this way. This is a cone. All right, so that is a cone. Now All right, so now it has formed a cone. Now this cone also looks like the corn mill. There is this figure which looks like a cone. We put corn or maize in it, then they will start milling it, so it's like a corn mill. All right, now initially this side from the question is 5 centimeters. That's the radius of the circle. When I bend, that 5 centimeters will coincide with the other part, which will now form the slant height of the cone. So from here, when I bend, okay, it will form the slant height of the cone. So this side is 5 centimeters. Now we have here to be the radius, for which we don't know, and we have the height, for which we don't know. So we are yet to find the radius and the height of the cone. This whole side, we call it the length of an arc. The length of an arc. Now this length of an arc, after I bend the sector, it will now become the circumference of the circle. So initially it was like this, which is the length of an arc. When I bend, it will now become the circumference of the circle. So viewers, I can say that the length of an arc is equal to the circumference of the circular top. So it's the same as the circumference of the circle. So now let's look at the length of an arc. Length of an arc. So from here, length of an arc is given as theta over 360 degrees times 2 pi r, and it is now equal to circumference of the circular top, which is also given as 2 pi r. Now I have made here to be a capital R and here to be a small r, so that there will be no confusion. Now from here, I can make this small r the subject, because this side I can divide here by 2 pi and divide this whole part by 2 pi, because 2 pi and 2 pi, they are common on both sides. So this can take off this, and this can also take off this. In that case, the small r, which is the radius of the circular base, is equal to theta over 360 degrees times the radius of the circle. So the r here is the radius of the circular top. Then this r is the radius of the main circle. So now my radius r is equal to theta, and from here the theta is 216. So we have 216 degrees over 360 degrees multiplying the radius of the circle, which is 5. So from here, when we have 216 divided by 360 degrees multiplying 5, we have 3 centimeters. So my radius r is equal to 3 centimeters. So this will be the radius of the circular top, or the radius of the cone. Alright, since we have the radius, notwithstanding, the sketch can also be of this form, Don't forget that. We can also put the sketch to be like this, where the R is here, we have H here, we have the 5 centimeters here. So here we have a right angled triangle. So viewers, here we have the radius, we have the height, we have the 5 centimeters, just like this. Because from the question said the base circle. So the base circle. I wanted to draw this so that you don't get confused. So now we have R to be 3 centimeters. And we are going to use this to find the height, because the height is perpendicular to the base. Then the slant height also looks like hypotenuse, for which we can get a right angle triangle. So let's get how we can find the height from the figure we have here. So from here, we can get a right angled triangle. So we have here to be 3 centimeters, which is the radius that we had here. We have here to be 5 centimeters, and we have the H, which is the height of the cone. So from here, we are going to use Pythagoras theorem. With Pythagoras theorem, I have 5 squared, which is equal to H squared plus 3 squared. We all know that 5 squared, we are going to get 25, which is equal to H squared plus 9. Then we are going to group like terms. So I have 25. When you take the additive inverse of 9, we have negative 9, which is equal to H squared. 25 minus 9, we have 16, is equal to 8 squared. Then we are going to take the square root on both sides. So square root of 16, and here square root of this. Then the square will cancel the radical sign. We have H to be 4 centimeters. So this will be the height of the cone. So from here, we can now find the volume of the cone. So C, we have volume of the cone. So in the beginning, I said that the volume of the cone is 1 over 3 multiplying area of the base multiplying the height. So we have 1 over 3 times, because the base is in the form of a circle, then it's going to be pi r squared times h, which is the height of the cone. And viewers, before we look at the volume, there is a mystery. Let me give you that mystery. The mystery behind cone is that when you have a cylinder which has, so before we find the volume, this is a cylinder. When you have a cylinder which has the same height as a cone and the same radius as a cone, then when I put water in this cone, 3 of this will be equal to 1 cylinder, if and only if the height and then the radius is equal to what we have with the cylinder. That is why pi r squared h is the volume of a cylinder, but 1/3 of the volume of a cylinder will give you cone. So when I divide water in the cylinder by 3, 1 of it will be equal to the volume we have in the cone. So from here, I can just have this. So you can see that we can insert cone in the cylinder, meaning that 1/3 of what we have in the cylinder is equal to 1 cone. So this is one mystery I want to give to my viewers so you can enjoy from here. So now let's continue with the volume of the cone. All right. Now with the volume of the cone we have 1/3 multiplying pi, and from here pi was 3.142. So 3.142 times the radius, we have radius to be 3, so we have 3 squared multiplying the height h, which is 4. So from here 1/3 multiplying 3.142 times 3 squared times 4, we are going to get 4713/125. And when you want to find the decimal of this, we have 37.704 centimeters cube, because we are looking for the volume. We are looking for the volume. So now the next part is the curved surface area. So now let's look at the curved surface area, D. Curved surface area of the cone. All right. So we also said that the curved surface area of the cone is given by pi RL. So we have 3.142 to be the value of pi. The radius, we have 3 multiplying the slant height, which is 5. So 3.142 times 3 times 5, we are going to get 4713 all over 100. So from here the decimal is going to be 47.13 centimeters squared, and this will be the curved surface area of the cone. Now the final one is the vertical angle. The vertical angle. So with a vertical angle, all right, so the vertical angle is this whole part. So I'll name here alpha, and this side will also be alpha. So when I'm able to get one of the angle, then I will add the same thing or multiply it by 2 to get the vertical angle. Now we have here to be 5 centimeters, we have the height to be 4 centimeters, and we have the radius to be 3 centimeters. So from here, in looking for this angle, we can use any of the trigonometric ratios, whether cos, sine, or tan. Any of them can be used because we have all the 3 sides of the right angled triangle. So I'm going to use sine to solve for this. So I have sine alpha is equal to, we know that sine is opposite over the hypotenuse. So we have 3/5. So I have alpha to be equal to sine inverse of 3/5. So sine inverse of 3/5, we have 36.8699 degrees. So as I said earlier, here if you want to find the whole angle is going to be, so therefore the vertical angle is alpha plus alpha because it's the whole of the angle. So let's make the conclusion here. So the vertical angle is equal to the first alpha we had 36.8699 degrees plus another 36.8699 degrees. So here we are going to add this and this. So this plus this, we are going to get 73.7398 degrees. This will be the angle. So you can correct to 2 decimal places, for which you are going to get 73.74 degrees. And this will be the vertical angle. So viewers, we will end here for today, and we are going to continue in my next video. So keep on watching Prof 1 tutorials. Don't forget to like the video if you find it interesting. Don't also forget to subscribe. Don't forget to comment and share for friends to also enjoy this most amazing video. Keep on watching. Stay tuned. Bye bye.